All right, welcome to the Explainer. Today, we're talking about something we use all the time, speed. I mean, we say it every day, right? But what does it actually mean? It seems so obvious, but when you dig in, it's built on this really simple, super powerful idea. And that's exactly what we're going to unpack right now. So let's start with that. What does it really mean to be fast? It feels so simple, doesn't it? We all have this gut feeling for what's fast and what's slow. But if you had to actually explain it, to define it for someone, what would you say? Well, it turns out that gut feeling you have, that sense of being fast, can be broken down into two really clear ideas. And it always comes down to the relationship between just two things, distance and time. And this right here, this is our intuition in a nutshell. We call something faster for one of two reasons. Either it covers more ground in the same amount of time, goes a longer distance, or it covers the same distance but in less time. It's always that trade-off. Okay, but here's where things can get a little tricky. The concept feels simple, sure, but how do you actually compare two different moving objects and prove, for sure, which one is the faster one? Let's make this real. Imagine we've got some data on two different buses. How do we figure out which one is actually the faster bus? Okay, so look at this. Bus A, we know it covered 150 kilometers, and bus B, we know it traveled for 2 hours. So, can you tell which one is faster? Nope, it's impossible. We've got a distance for one and a time for the other. The data points are like apples and oranges. They just don't connect, so we can't make a fair comparison at all. So how do we solve this puzzle? Well, luckily, there's a really simple, kind of elegant solution. We just need to find a common yardstick, something we can use to measure both of them against. And that common yardstick is something called unit time. This is the key idea right here. We stop looking at the total journey, and instead we focus on a standard, fixed chunk of time. Could be 1 second, 1 minute, or, like you see most often, 1 hour. This gives us a super simple 3-step method. First, you just pick your unit of time, let's say 1 hour. Second, you figure out the distance each of those buses covered in that one single hour. And third, you just compare. The bus that covered more distance in that hour is, by definition, the faster one. Easy! So with this whole idea of a common yardstick, this unit time, we now have all the pieces we need to build the official scientific definition of speed. And the source material we're looking at today puts it perfectly. This is it. This is the core principle we've just figured out. If you want to know what's faster, you have to compare how far they go in the same chunk of time. And there it is, the definition of speed. It's simply the distance covered by an object in a unit time. That's it. So clean, so simple, and incredibly powerful when you think about it. Now, that's great in theory, but let's make it a little more real. Let's look at an example you hear all the time to see how this definition really works out in the wild. So you've heard this a million times, right? Someone says a car is moving with a speed of 50 kilometers per hour. We use phrases just like this constantly. But now we know exactly what that means. Let's really break down what 50 kilometers per hour is telling us. That per hour part, that's our unit of time. It's 1 hour. And the 50 kilometers part, that's the distance the car covers in that single hour. Speed is just the name we give to that entire relationship. And that, right there, is the most important takeaway from all of this. Speed isn't just a number. It's a rate. It's the rate that connects distance to time, telling you exactly how much ground you're going to cover for every single unit of time that goes by. But this brings up a final, really interesting question, doesn't it? We've assumed this car is just cruising at a perfectly steady 50 kilometers per hour. But what happens in the real world, when a car speeds up or slows down in traffic? What do we call that whole concept? That's a great question and maybe a topic for another explainer.